In a previous video, you learned about the resting membrane potential. In the present video, we want to ask, what can affect the resting membrane potential? When a neuron fires, it releases chemicals called neurotransmitters from its presynaptic buttons. Those neurotransmitter molecules travel across the synapse and bind to specialized receptor molecules on the membranes of the postsynaptic neuron. When neurotransmitters bind to postsynaptic receptors, they typically have one of two effects. The first possible effect they might have is to hyperpolarize the receptive membrane, that is, increasing the polarization of the membrane potential. We can see this hyperpolarization as a downward deflection on the oscilloscope. Postsynaptic hyperpolarizations are called inhibitory postsynaptic potentials, or IPSPs, because they decrease the likelihood that the neuron will fire an action potential. The second possible effect that a neurotransmitter might have when it binds to a postsynaptic receptor is to depolarize the receptive membrane, that is, decreasing the polarization of the membrane potential. We can see this depolarization as an upward deflection on the oscilloscope. Postsynaptic depolarizations are called excitatory postsynaptic potentials, or EPSPs, because they increase the likelihood that the neuron will fire an action potential. EPSPs and IPSPs travel passively from their sites of origin on the postsynaptic membrane in much the same way that electrical signals travel through an electrical cable. And the speed of transmission of postsynaptic potentials is so rapid that it can be considered as instantaneous. It is important to note that both EPSPs and IPSPs are graded responses. That is, they can be any one of many different sizes, all depending on the strength of the stimulus that elicits them. One final thing to note is that the transmission of EPSPs and IPSPs is decremental. The size of EPSPs and IPSPs decrease in amplitude as they travel across the neuron. In summary, EPSPs and IPSPs travel very rapidly, they are graded responses, and they are decremental in nature.